Now we're going to look at using the power reduction formulas to simplify an expression. So a power reduction formula takes something down from being squared down to being linear. Now, you should see these three examples here, these three formulas. Sine squared theta is 1 minus cosine 2 theta over 2. Cosine squared theta is 1 plus cosine 2 theta over 2. And tangent squared theta, by the way, tangent is just sine over cosine, so sine squared over cosine. You get the 1 minus cosine 2 theta over 1 plus cosine 2 theta. And how do we use this? Well, this is a classic example. You probably see this in any textbook. Write an equivalent expression for cosine to the fourth power of x that does not involve any powers of sine or cosine greater than 1. So I want to point out, though, when we do this, when we reduce that down, we end up with a 2 theta, it goes from theta to 2 theta inside. And we're going to see this happen probably, I think we're going to do a couple of times on this. So what we have is a cosine to the fourth power of x is cosine squared x times cosine squared x. Okay, well, what is cosine squared x? Using the power reduction formula, we have 1 plus cosine 2 theta over 2 times 1 plus cosine 2 theta over 2. And I want to just stress that each of these is a cosine squared theta. Oh, they're doing x, so x. Okay, so let's go here and erase that theta. Come back with an x. So we have fractions being multiplied, so I think it's easiest, I think it's cleanest to see this if we were to take that. Well, there are many ways to represent this. I don't want to stress people out with the fractions, but 2 times 2 is 4. There we go. Now we have basically an a plus b times a plus b. We have an a plus b squared is a squared plus 2ab plus b squared. So a is 1, b is cosine 2x. So we have 1 squared plus 2 times 1 times cosine 2x plus cosine 2x squared. So what do we have? Oops, didn't mean to do that. There we go. We have 1 plus 2 cosine of 2x plus cosine squared of 2x all over 4. So we're close, but we still have something with a squared in it. So I'm going to have to apply it again. And I think it's easier if I rewrite this as 1/4 times 1 plus 2 cosine of 2x plus cosine squared of 2x. So we can reduce this term here. 1/4 times 1 plus 2 cosine of 2x plus, and then the cosine squared of 2x, it was 1 plus cosine of 2 times 2x. That's over 2. So that this was my cosine squared of 2x. So it's becoming cosine of 4x. Okay, so what do we have from this? We got the 1/4 out front times 1 plus 2 cosine of 2x plus 1/2 plus cosine of 4x over 2. And let's just clean this up. We'll add the 1 and the 1/2, and I need to distribute this 1/4 through. And I'm running out of space. So I guess I'll do what I can. 1/4 times 1 plus, I don't know, 1.5, so I'm going to call that 3/2. 3/2 plus 2 cosine of 2x plus cosine of 4x over 2. So if I distribute the 1/4 through, we end up with 3/8 plus the 1/4 and the 2 reduce that to 1/2. So cosine of 2x over 2 plus cosine of 4x over 8, because 4 times 2 is 8. And there's an answer that works, so the previous one works as well. Okay, moving on. Use the power reducing formulas to prove sine cubed of 2x equals 1/2 sine of 2x times 1 minus cosine of 4x. So let's see here. We could treat this as, and this is not an absolute value, that's a bracket. So sine cubed of 2x is going to be sine of 2x times sine squared of 2x. Well, this is sine of 2x, as our target right here is. Sine squared 2x, if we go back to our power reducing formulas, was going to be 1 minus cosine of 2 times theta. So here's our theta, we're doubling that over 2. So we'll do 1 minus cosine of 2 times 2x over 2. So what I can do is I can take this 1/2, since multiplication is commutative, and I can move it over here. So it'd be 1/2 sine of 2x times 1 minus cosine of 4x. And that's it. And that's it for this video.